Hej, ni hör mig, vad bra. Trevligt att vara här, trevligt så mycket folk kunde komma mitt i dagen på en torsdag. So I'm going to present my PhD thesis, Designing Out Waste. And it's basically, I'm gonna summarize this in half an hour, but the thesis is available at the public Chalmers digital library. So just you can download it and look into more details. I don't have time to go through all of it. And why am I looking into waste? Well, I'm an industrial designer to start with, and even though I see that these products here have a value with fulfilling the function that they need to fulfill, like transporting liquids in a very lightweight packaging, when they're located out in nature like this, then it doesn't fulfill any purpose, and it actually makes a bigger problem than what we had before. And as an industrial designer, I feel a bit responsible, because it's basically product development that's behind this that hasn't really seen how these products have to fit into the larger scheme of things. And it's not a small amount of material that we're talking about. Waste volumes have been growing for the last century almost, kind of steadily. And the materials are very mixed and available everywhere. And in many cases, they have raw materials that are scarce, like in electronic waste, rare earth metals or different materials that now are easier to find in landfills than in mines. So there's more copper in a Chinese landfill than there is in a copper mine. But we don't have the technology to take out this copper from this sort of material. We have it to take it out from stones. So there's something intrinsically wrong with this way of doing things. And it's basically the side effects of a linear production system that we have. We take material resources from nature, and we produce raw materials that then we send out to manufacturing to develop goods, any sort of product that then a user will take in and make use of it for some purpose. And when they're done with this product, they're gonna throw it away. Hopefully, it'll come to a waste management system that'll take care of it and put it away in a way that does not harm the environment. But there's many people that have proposed that we'd rather, instead of having this linear production system, we should actually use what we're throwing away to generate tomorrow's production. Industrial ecology proposed this, and they started by saying within different industries that generate waste, we could connect that to another industry that could then use that waste as their input material, and in that way reduce the amount of waste that we're generating. Cradle to Cradle said, well, we can design things so when the users are done with it, we can take it back. And then we can make new products based on the same materials. We own the materials, so we'll actually put more value in these materials that'll come back to us. And then even the circular economy has gone a step further and said, well, we actually have to have a waste management system that supports this sort of material recirculation. And this is very, very on topic now, and within regulations in the EU and Sweden. It's a very, very buzzword, the circular economy. So what I've been dedicating my last 5 years is, why don't we have a circular system? Everybody's talking about it. Everybody sees that it's better, but we don't have it yet. So why? Why not? What hinders material recirculation in practice? And as you guys can see, this is a very broad and abstract question, especially when you start doing your PhD, you don't really know where to start here. So this is where I started, because I want to know what is wrong today. instead of what are the good examples that can recirculate material. What are we not recirculating and what are we actually discarding or even incinerating? So this was my starting point. And it's fascinating how quickly you can get like a professional deformation. And I'm out on trips and I have like a lot of holiday pictures about landfills in, in the side or junk yards in the side of the train tracks or etc. You end up getting an eye for it. You see it everywhere, because it is everywhere. So this is the starting point. We have a production system that generates products for users that then discard them into a waste management system. And what I was interested is in the link that's missing there between waste management to production. So the first question that I looked at was, is it possible to design with waste? Has it been done? Is there a structure to do this? How can we educate designers to design with secondary materials rather than raw materials? And then, well, we can only design with what we get. And if we get everything mixed, then it's really difficult to design things. So how about waste sorting? How can it be improved? Is it a way to make it easier for those materials to be cleaner so they can be put back into production? And being an industrial designer, I wanted to know if designers working at the production stage understand and relate to waste. Do they see their role in this waste generation society that we have or not? Do they care? Are they tools for them? So these three questions were addressed in my thesis as three different topics. And these three topics had different studies in each of them. I'm going to go briefly tell you a little bit about them. But the three topics together make an overview of the current situation of material recirculation. And that overview helped me puzzle together underlying barriers for recirculating materials, and then to come with some sort of suggestions to overcome this. Those underlying barriers and suggestions are very general. They're at a very broad level, so it's not kind of very, I guess when I came to it, it was like, yeah, but everybody knows this, you know, like you've seen it again and again. You go to conferences about waste and everybody agrees that there's problems that come up here. So it's just corroborating that with the studies I've done. Okay, but quickly, I'll take you through the studies. Designing with waste is summarized very well in this picture because this is part of a hairdryer. It's the plastic fraction of electronic waste. That when electronic waste gets processed and crushed, they separate these plastic flakes that then can actually be melted, filtered, melted, and made pellets again that you could use to make other plastic products. This pellets of mixed plastic electronic waste has been part of a double doctoral degree at Chalmers between the chemical engineering and the material engineering departments. So this is something that has actually been developed and tested, and that they have good knowledge about how this material is. It's a secondary material. It's not as good mechanical properties as virgin plastic, but it has a lot of applications in any case. But what I did was suggest that design students did their thesis in developing products from waste. And here we collaborated with Stena Recycling and Semcon, and Stena Recycling said, we get all these materials in large volumes and we cannot do anything with them. We today either incinerate them or send them to landfilling. So there were 6 or 7 materials that the students could choose from. And this collage shows the different materials that the students chose and different final concepts that they presented in their thesis. So if you start here, it's the plastic sleeving from cables. It's PVC purely, but it has traces of different metals. And that was a topic for 2 theses that developed indoor dividers with acoustic properties and outdoor flooring. Then you have polyurethane foam that was used in 2 theses, B and F. to also develop different kind of products. And then this electronic plastic fraction of electronic waste was also used to propose the casings for thin clients. And finally, C up there was a plastic fraction from an industrial production process. It was a clean fraction, but they were not making use of it. All of these highlighted that it's plastic that is a big problem. But what we were interested in is how does this process happen? Because when we started looking at it, we didn't find any research about how to design with waste. There's a lot of examples, but no actual guidelines to how to do this. So what we found is that this is a combination of a normal, common design process that maybe the ones that are not familiar with it, you start with a broad idea about what sort of product you want to do. You ideate, you make several suggestions of what could be improved, and then you filter those down and you iterate a lot to get to a final product. So you create ideas and then you choose from those, and then you create ideas for another part of this, and etc. But to design with waste, this starts earlier. You need to start with the material. You need to analyze it and know the properties of the material to be able to create ideas about where to use it. And then choose from those ideas. And then you come to, okay, this is a type of product that I want to do. So this pre-process stage was much longer than we expected, basically because the students had no good material information. This analysis of the material was almost done by themselves, but they're no material experts. So it was challenging, especially when they found, in the case of PVC, depending on the source, they found contradicting information. Was it too toxic? Could they use it indoors? It was not reliable at all. So the 3 steps are analyze, ideate, and screen. And when you have chosen, but you're just in the beginning of the process again. It's just a type of product. So it makes the whole design process much fuzzier. So these are the barriers that we found. Irregularity in the material to be used, little reliable information about the material, and the lack of a traditional design brief. Designers normally, or design students normally struggle with the fact that designing is a fuzzy area. You don't really know what you're going to. No one can really say what's the best chair or etc. But in this case, it was even, you can do whatever you want. You just have this material. You don't even have a need to go from. So it became very difficult for the students. So the suggestions, well, we describe the process, so we know we have to analyze, ideate, and screen. But first, you have to collect the material. And you have to investigate and test the material properties. And these 2 steps, in our case, the first step, the collection and sorting, was done by Stena Recycling. But in some cases, the case of the plastic fraction of electronic waste, then there was some other actors that had investigated and tested the material properties. But for some material, that wasn't available at all. So if those initial steps could be done by someone that was not the designer, then we would have gained time. That was it with designing with waste. Topic 2 was waste sorting. And well, here I worked together with a housing company in Gothenburg, and we dived into waste sorting in apartment buildings. And you see a lot of interesting things. Especially, you see that the system is not adequately developed or formed to take in the user's need. This Christmas tree is in the paper and cardboard recycling. There is a purpose here. There is an intention. It's cellulose. It might work. They want to sort it correctly, but the system does not adapt for it. And this is a requirement that comes every year. So we did several studies, and we focus mainly on biodegradable waste, food waste, because when we do waste composition studies, it's the largest fraction by weight that comes up in the mixed waste. And ironically enough, these housing areas have the opportunity to sort organic waste. The city in Gothenburg collects organic waste for making biogas. So they have the opportunity to sort it, but they don't. So we tried taking out the lid of the containers for bio-waste and trying a new bag that has a sealable rim on it to see if it improved the hygiene of sorting in these sort of waste sorting rooms. We even put fly traps behind so we could count the flies depending on the different treatment that we had. So I actually spent several hours looking at fly pictures and trying to. There's some of the flies that are fake flies that come with the trap, and others that are the real flies. So it's, yeah, interesting in the end. But the main barriers we found for waste sorting are not only for the organic waste, but more general, is that this central collection in apartment buildings provides anonymity. And it makes it very difficult to give feedback. The housing company is the one that has contract with the waste collectors. So they're the ones that know how much waste is generated, if there was a wrong sorting, or etc. And this information is very difficult to give to the tenants. Because, yeah, you can tell the whole building that there was a problem, but you don't know who was responsible of mixing up the waste. And since it is a common infrastructure, it suffers a tragedy of the commons. Nobody's really responsible for keeping it tidy. Even though the housing company tries, they're not the ones that act in these spaces either. And the provided categories do not always correspond to what the users wish to discard. And another interesting fraction that we found was textiles was very commonly discarded mixed waste in their own bag. And if you think about it, at home, where you clean your wardrobe or whatever, you put that into a bag, and it's already separated. At home, you don't mix it with the trash that's coming from the toilet or in the kitchen. But you come to the waste sorting room, and there's no place for it. So it's a fraction that at home is sorted, but in the system it's not collected. So this housing company, together with Renova, tested allowing tenants to sort out their textile waste, and got more than 2 tons of textiles in the first month. So just thinking about the fractions in terms of the tenants rather than the system makes a big difference. And it's difficult because to improve this, we need convenient infrastructure. But what is convenient infrastructure? This is how I sort waste at my place. You see the paper, the 2 bags in the middle are plastic, and in the corner there is the rest. The biodegradables are not here. But this changes. Every flat I've lived in has a different system. It's either the bags are located in a different place, I go out with them more or less often, depending on where I have to drop them off, etc. But it's important to understand the user to be able to provide a convenient system. And the users are different and will change over time as well. So the system has to be dynamic. And today it's not. That was waste sorting. Now we're moving on to the third and last topic, waste and design. And here what we did, we interviewed a lot of designers that had worked with waste and waste management professionals that had worked with design, or designers, to see if there was any collaboration, how they saw the potential for recirculation. And we gathered a lot of examples of products that exist on the market made of secondary materials, or sometimes clean fractions, sometimes not that clean. And we were interested in seeing how that process was done and how these designers actually see their role as recirculating agents. And we found the main barriers is that designers describe only a partial, very unstructured relation to waste generation. Some designers lack the interest completely. They say, no, somebody else takes care of this. We did a web survey to know how many designers actually worked with the end-of-life considerations in their products in the last project they worked on. It was less than a third. And I thought, this is something that we've been talking about for 20 years, you know, every designer is aware of this. No, it was only less than a third that had tried it, and of those, it was a fraction that felt that it was their obligation. There were some people that had not tried it, saying, no, that's taken care of somebody else. That happens in another stage of the production process, etc. Then, and because designers also work in tight time frame, like everybody else, other things get prioritized. If it's not defined in the design brief from the start, it's not included. So this is something that we're missing, really. So suggestions, well, we would need a better understanding for this relation, and how designers' decisions influence waste generation. What are the possible recovery routes that they have? And how to consider the actors involved in recirculation, because a quote of one of the designers I interviewed was like, yes, we can design for recycling, but that it gets recycled, it's not our task to do. It's a lot of other people in the way. It's the user that's going to discard it. It's the waste management structure that is in place so that it is convenient to discard. It is the market possibilities of actually recycling this product. So we can design for recycling, and there's many examples of design for recycling that are very kind of successful. But when they find their way to the waste management stream, they're just crushed and incinerated. Even when they come into an industrial recycler's facility, one of the famous examples of cradle to cradle is one of these office chairs that takes a minute to disassemble, but it takes 3 seconds to crush. So if it doesn't come back to the industry that made it, it's not going to be disassembled, because there's no value in the recycling market for it, unfortunately. So I put together these 3 topics and saw if there was anything that was recurrent, that came up again from one to the others, so we could try to fit this all together into one thesis and argue that it was a same thing. So I found 6 underlying barriers for material recirculation, and they're common. People have seen them before. I've just put funny pictures associated to them so you'll remember them. Here we go. Complexity of the sustainable waste management system. This is not trivial, because the more fractions there are, the more actors involved, etc., it's harder to be able to plan for it. And if we want designers to be able to design for a waste management system that'll take in, they have to understand it. But today, they don't. And the interesting thing is, today you ask people that work in waste management system, and they'll describe a system that is not the same system that people either from the commune or from housing companies, so every actor has their own view of the system, and they're all valid and they're all correct, but the system itself is a bigger monster in a way. So sometimes you end up feeling like this. There is a lot of intention behind, but you don't really know what you're supposed to do. There's a lack of knowledge of secondary material, and this is a big challenge. This is something that material experts should be dedicating their time to, instead of generating new composites that we cannot recycle and putting electronics into everything that we cannot recycle. They should start thinking about how to standardize the flow of secondary materials to be able to assure quality that can be then used in production. There's lack of information. It's not because there's no information, it's because it's not there when we need it. And this happens for all the different studies that we've done. That there is a lot of information, and we live in a society that is overloaded with information. But when you have to make a choice, you're like, oh, I don't know, should I do this? unfortunately. And this is more than anything a lack of communication, because housing companies feel that they work with communication all the time, but when you ask the tenants if they've been informed about how the waste sorting system works, they're like, yeah, I don't think so. So they might be putting out information, they're not really talking. And that's the main problem. There's undefined responsibilities. Anybody that lives with another person knows this. Or even if you live alone, you struggle with your future self on who has to do the dishes. There is a common space that everybody is responsible. It means nobody takes full responsibility. And we know this problem, we recognize it. So hopefully we should be able to solve it as well. There's also lack of control. You want to recycle, but the system is not there for you. You want to design for recycling, but you're not the one that's going to throw away the system. You have to live with the fact that you don't control it. You're putting things into a flow, somebody else is driving, you have to live with what you can suggest here. And finally, sorting out our material flows takes more time and effort than not doing it. It is an effort that is within our reach, but we have to be very convincing to argue why we should do it, because we always take the easy way out. I mean, that's the way of nature. You follow the easiest route, the path of least resistance. Now we have to be very active in the choice of saying, no, we have to do the harder thing, because if not, it's not going to work in the long run. So these are the main barriers for material recirculating. And there are problems that we see in several different aspects of life, which means that I could get pictures for it. So there, for hope, we can hope to see some sort of solutions from other places brought into this realm as well. And all these came and were found in the different parts of this recirculation system, like of the different stages of material use. So together they actually describe the barriers for this circular system that we want, rather than just barriers in one of these aspects. So what can we do about it? It's not enough to paint a grim picture. You have to come with some sort of suggestions. I came with two types of suggestions. One, regulations that could support material circulation, and then better understanding among actors. The regulations address different aspects and different stages. One of the regulations should be that all materials available should be recirculated. And this is rather strong, because this means that we shouldn't be able to use materials that do not have a recycling system in place. There should be transparency about the materials that are used in production. We should know what we're putting into our products, because we should be able to pick them apart to use them again. This goes against all private companies' interest of keeping their product development process secret. So this is also very harsh to try to implement. We need to establish secondary material quality standards. And there is work on this in the EU's the path for circular economy within the EU. They talk about work in material standards for secondary materials in the material fractions that need it, specifically plastics and textiles that are today far behind. And we should demand that recirculation is included in the design phase. This should be something that is required in every design brief. That's also very strong. That's been suggested before by other researchers. But if we don't have a regulation in place that makes us plan for this, then we're just going to continue in a linear system. So those were my supports for regulation. or suggestions for regulation. And then better understanding about actors. We always say we should talk more, we should work together, we should kind of get along to get things to work. My specific suggestion for this was to put designers in the waste management branch. Heard another researcher say we need waste managers in production systems, and we do. I think it's this cross-pollination that is necessary to be able to get these two corners to interact. But having designers in the waste management system, I think, will facilitate to include the service users when you're developing waste management systems. So to design, have a user-centered waste system rather than a process-centered waste system that we have today. And it would facilitate the collaboration with production systems because they could understand the requirements set for production. Yes, thank you very much.